In this lesson, you will continue to solve similar figures. We will work with the triangle proportionality theorem. It says that if a line parallel to a side of a triangle intersects the other two sides of the triangle, then it divides those sides proportionally. So let's look at our figure here. We have a triangle. This line intersects the two sides of the triangle, and that line is parallel to the third side. So that means that the sides that it intersects are divided proportionally. AE with EB is equal to AF with FC. Those ratios are equal, meaning they are proportional. This is also known as the side splitter theorem. Let's look at example number 1. We're asked to find PN. So PN is this part of the side of the triangle. We notice that we have a line that is parallel to the side of the triangle. So that means that these sides are divided proportionally. So we can set up our proportion to solve. If a line intersects two sides of a triangle and it is parallel to the third side, then those two sides are proportional. So PN with the same side LP there, those parts are going to equal QN with MQ. Being careful that corresponding parts stay lined up in your ratio. So X goes with 3 and 5 goes with 2. It does matter how you set up these ratios to make your proportion. Always line up those corresponding pieces of the triangle. Now we'll cross multiply to solve. So we get 2x equals 15. 2 times x is 2x. 3 times 5 is 15. And then we solve by dividing by 2. So x equals 7.5. Let's look at example number 2. Here we're asked to find Rn, so label that with an X as our unknown side. So that side Rn goes with the side that's labeled 10. So this Rn, we're going to keep it with the same side, Mr, which is labeled 10. But notice we need this piece here to do the other side of the triangle. So take 13. If we know the full measure is 13, if I take away this piece 5 that we know, that will give us the remaining leftover part of the side of the triangle. So 13 minus 5 gives us 8 for that piece. So now we're ready to set up our ratio. X goes with the 10, and now we'll have 5 with the 8. We needed to use this 13 to find the 8 by subtracting the piece we already knew, that 5, away from 13. Now that we have our proportion, we can solve. Cross multiply, we get 8x equals 50. 8 times x and 10 times 5. And then we solve by dividing by 8. We are asked to round to the nearest tenth, so the tenths place is 1 decimal. Behind that tenths place, we have a 5, so that will make this round up. Our answer is 6.3 for that length for Rn. Let's look now at example number 3. We're asked to find JU. We're going to round to the nearest tenth. So JU is this side length here. We do have the parallel side or parallel line to the side of the triangle. So that means these are divided proportionally. JU goes with the UK, and 27, the JT, will go with 45, the TL. So we can set up our ratio. But notice for JU, it is represented by -4 plus 4x. So we will just use that for that piece of the side. We'll set that up with the 27 over 45. Again, cross multiply to solve. Here, when you cross multiply, we need to make sure that we do 45 times the whole thing that represented JU. So use parentheses. You can go ahead and distribute. However, I'm actually not going to distribute here. 40 times 27 is 1,080. Here at this point, we could distribute, as I've already mentioned, or because 45 being multiplied, we could divide, and that's going to help us work with much smaller numbers. So by dividing both sides by 45, it does get rid of the 45, but it's also going to make that 1,080 become 24. A lot easier to handle those smaller numbers. Here, when we continue to solve, we're going to need to add 4 to both sides. That is a -4. To make it cancel, we would add. Make sure you do that on both sides. So we get 4x equals 28. And finally, we solve for x by dividing by 4. We're not done at this step. That's just what x equals. But if you notice, JU is -4 plus 4x. We need to plug in that x to actually find the length of JU. So plug in 7 for x and work that out. -4 plus 4 times 7 gives you 24. Example number 4. We're going to apply this to some contextual problems. Beth is 5 feet tall. At noon, she measures the length of a statue's shadow to be 62 feet. She stands 45 feet away from the statue so that the tip of her shadow meets the tip of the statue's shadow. We're asked to find the height of the statue to the nearest hundredth of a foot. So the height of the statue is our unknown, so that's our variable x. We have this height of the statue that we're trying to find, and it would correspond to the height of our person, who is Beth. So this actually is not going to need to be used like the side splitter theorem because we actually don't know the measurements of the other sides. We would need to use just regular similar triangles and their corresponding pieces. We will want the measurement between the person and the tip of the shadow. So take the whole length, 62 feet, and subtract the 45 feet. That tells us it is 17 feet between the person and the tip of the shadow. This will help us set up our corresponding sides for the triangle. If you need, always draw the smaller triangle separate of the larger triangle so you can visualize those corresponding pieces. So the height of the shadow x is going to correspond to the 5, the height of the person. So that is our first ratio, and that is going to equal, go back to the shadow, and we have 62 feet for that full length of the shadow, corresponds to the 17 that we just found. So this is the proportion that we would need to solve to find the height of the statue. Of course, cross multiply, so we get 17x equals 5 times 62 is 310. So 17x equals 310, and we divide by 17. This does tell us to round to the nearest hundredth of a foot. So 10th hundredths place is the second decimal place. We look behind just that one place. We don't just keep looking everywhere. Just one decimal place behind the hundredths is a 5. That 5 will make this round up. So everything else behind that 5, you can just drop off of your answer. You don't need it. You only look at the one decimal place behind where you were told to round. So we'll have 18.24 rounded to the nearest hundredths. That 5 does make this round up to 18.24. So the height of the statue is approximately 18.24 feet. Let's take a look at number 5. A pole 7 feet tall is used to support a guy wire for a tower, which runs from the tower to a metal stake. So we have this 7-foot pole. The guy wire from the tower to the stake would be down here. So after placing the pole, we have a measurement of a distance from the pole to the stake. So from the pole to the stake is 4 foot, and from the pole to the tower is 18 foot. We're asked to find the length of the guy wire in the nearest foot. So again, looking at corresponding triangles and how they can be proportional based on their sides, we do have this smaller triangle that's going to correspond to the larger triangle. And since the guy wire is the hypotenuse of this larger triangle, so if you notice this bigger, larger triangle formed with the guy wire and the tower, that is the hypotenuse of a right triangle. So we would actually need the hypotenuse of this smaller triangle to have corresponding sides. So let's solve for that hypotenuse. To find the hypotenuse, we would use Pythagorean theorem. A squared plus b squared equals c squared. So the legs squared and added together equals the hypotenuse squared. So we find that c squared equals 65 because 4 squared plus 7 squared is 65. When you take the square root of 65, it actually gives you a decimal. We're not able to simplify the square root of 65 because its prime factors are 5 and 13. So it's actually best just to use the square root of 65 in our work, because if we rounded the answer now to a decimal, it would make our final answer slightly off. So it's better to use this exact value of the square root of 65. So now we can line up our corresponding sides. So the guy wire, this hypotenuse of the large triangle, is going to correspond to the square root of 65. And then we'll actually need the total of this length of the bottom of this triangle. So the 4 foot and the 18 foot, we can add those together. So that gives us 22 foot for that full length of that larger triangle. The x, the piece we're trying to solve, corresponds to the square root of 65. The hypotenuse corresponds to the hypotenuse. But then we'll need this full length of the base of this larger triangle to correspond to the 4 foot of the smaller triangle. So 22 corresponds to 4. Corresponding sides of a triangle are proportional. So now we can cross multiply. So 4x equals, when you cross multiply 22 times 65, because the 22 is outside of the radical and the 65 is inside the radical, we would just write it in that way, 22 the square root of 65. You would not want to multiply 22 and 65 because they're not actual values you can multiply together. We would just write it 22 the square root of 65. Once you divide by 4, this is where we can type it in a calculator in order to round our answer to the nearest foot. So x equals, if it's rounded to the nearest foot, that's our nearest whole number. Look, 1 decimal place behind. So looking at that 3, all the other numbers do not matter when rounding. Only look at the 1 place behind where you're told to round. So this 3 will leave this as the same 44 foot. So the guy wire is approximately 44 feet long. And now for example number 6. To indirectly measure the distance across a river, Jason stands on one side of the river and uses straight lines to a landmark on the opposite bank. Jason draws the diagram below to show the lengths and angles that he measured. Find TW, so TW, which is the distance across the river. We will round our answer to the nearest meter. So that is our unknown piece, the T to W across the river. If you need to draw that smaller triangle off to the side so that you can line it up with the larger triangle, which would be similar triangles. So when we set up our ratio, the corresponding sides will be proportional. So notice X from this smaller triangle will correspond to the whole length of the larger triangle, so X plus 41. It does matter that we need that full length, so we would just add X with 41 to get that length of the largest triangle. Then we want to set up another ratio. So the 64, the base of this smaller triangle, is going to correspond with the 90. Of course, the 90 is the base of that larger triangle. So now we solve by cross multiplication. Of course, the first cross multiplication, 90x, is going to equal, we'll do 64 times the whole thing, x plus 41. If I divided by 64 at this point, that would cause a fraction here with the 90 and 64 being divided. So if you're okay with working with those fractions, feel free to do so, but I'm going to actually distribute at this point. 64 times x and 64 times 41. So we get 90x, just bringing that down, equals 64 times x is 64x, and 64 times 41 is 2,624. We will need to solve for x by moving the variables to the same side, so subtracting 64, and make sure you take the variable x, so subtracting 64x from 90x gives us 26x. Of course, we're going to just bring down this 2,624. Our final step to solve for x, we will divide by 26 to find, if we rounded to the nearest meter, that would be the nearest whole number, because there is a 9 here in this first decimal place that makes it round up to 101. So it's approximately 101 meters across the river. So when working with similar figures, we have learned that the corresponding angles are congruent and the corresponding sides are proportional. But also, if we have a line that intersects the triangle and it's parallel to the third side of the triangle, then it does divide those sides proportionally, and we can set up and solve a proportion. This is the triangle proportionality theorem, and also known as the side splitter theorem.